In this next section, we look at how to perform inferences about a population total using cluster random sampling. Now, one estimator of the population total, tau, is given by the following. Tau hat equal to cap m times y bar, all right, where y bar is equal to the sum of the y values divided by the sum of the m sub I values in the sample. Now, this estimator requires knowing cap m, which you'll remember is the population size. So if the population size is not known, then this particular estimator cannot be used. But if it is known, we can use this. Now, an estimator of the variance of the sampling distribution of this version of tau hat, this estimator of tau, is given by this expression here. And note that it does not involve cap m. All right, cap m is involved only in the estimator of tau itself. Once we have the estimator of the sampling distribution of the variance of tau hat computed, we can take its square root, all right, to get the estimated standard error of tau hat. And then once we have that, we can multiply it by 2 to get an approximate 95% margin of error associated with tau hat. All right, and then down here on the bottom of slide 19, we have the formula for the confidence limits. We also have this sum of the squared differences between y sub I and the y bar times m sub I values. We calculate that using the expansion formula that we looked at in the previous section. All right, so continuing the previous example, estimate the total income of all residents in the city, compute the approximate 95% margin of error associated with this estimator, and construct an approximate 95% confidence interval estimate of the total income. Now suppose that it's known that there are 2,500 residents in the city. So if we know that, then we can use this particular estimator of tau. So the point estimator of tau, tau hat, this version of it at least, is 2,500 times y bar, which we found to be 8.8013. And so that estimator is 22,003.25. Then we need to estimate the variance of this estimator of tau. And so again, this is the formula that we use. And we've already calculated this expression here in the previous example, so we don't need to recalculate it, right? There it is right there. And so the estimated variance of tau hat is 4,107,760.855. The square root of that, which gives us the estimated standard error of tau hat, is 2,026.76. All right, the margin of error is obtained by multiplying that estimated standard error of tau hat by 2, all right, to give 4,053.52. And so an approximate 95% confidence interval estimate of tau is 17,949.73 up to 26,056.77. And remember that, again, these data are in hundreds of thousands of dollars. Now, we have another estimator of the population total, which we can use if we don't know cap m, the total number of members in the population. And that is given by this expression here. So it's cap n, which is the total number of clusters in the population, divided by the number of clusters in the sample, times the sum of the yi values. Now keep in mind here that we can't take this sum and put it over little n and say that's y bar. Remember, y bar is something different. Y bar is the sum of the yi's over the sum of the cap m sub i's. An estimator of the variance of the sampling distribution of this version, or this estimator of tau, this tau hat, is given by this expression here on slide 22. And notice that we have a little bit different expression out here in this summation. It turns out that if we take the 1 over n minus 1 times that summation, okay, that turns out to be the variance of the yi values. So once we've calculated this, we take its square root to get the estimated standard error of tau hat, and then we multiply that by 2 to get our approximate 95% margin of error associated with tau hat. And then we use the point estimator of tau along with the margin of error to get the lower and upper end points of the approximate 95% confidence interval estimate for tau. And so let's look at an application of this. So continuing the previous examples, estimate the total income of all residents in the city, assuming that CAPM, the total number of residents in the city, is not known. Compute the approximate 95% margin of error associated with this estimator, and then construct an approximate 95% confidence interval estimate of the total income. All right, so the point estimator of tau, the total income, is CAPN over little n times the sum of the y's, so 415 over 25 times 1329, and so we get 22,061.4. So that's our point estimate that we calculate without knowing the population size itself. Now, in order to calculate the estimated variance of tau hat, we have to calculate this quantity here, which is at the right-hand side of that variance formula. And like I said, this expression here, if you look at it, looks like a variance, doesn't it? Well, it actually is. It's the variance of the yi values. All right, and so that turns out to be 474.5567. And so we plug that into the formula here. Now we make sure that we're plugging that 474.5567 in for this whole piece right here, the 1 over n minus 1 times that sum. We want to make sure we don't divide by n minus 1 twice. All right, and so then when we do this, the estimated variance of this tau hat is, let's see here, so that's 3,072,279.86. The square root of that is 1,752.792. We multiply that by 2 to get our approximate 95% margin of error associated with tau hat, and so this is 3505.58. And then once we have this, then we can construct the approximate 95% confidence interval estimate for tau, which ranges from 18,555.82 up to 25,566.98. So to estimate a population total using cluster random sampling, we have two potential estimators of tau, two versions of tau hat. The first one we looked at requires knowing what the total population size is, CAPM. The second one does not require that, so if we don't know the total population size, then we can't use the first. We would have to resort to using the second one. All right, so that's the end of this video. We'll pick up with the next video looking at how to estimate a population proportion using cluster random sampling.